Okay, welcome back. Chapter 9, Resource Management. It makes sense. First we did scope. In scope, we collected all our requirements and built a work breakdown structure with deliverables. And then we looked at cost and schedule management, which had activities that needed a certain amount of cost associated with it and time. But those will all change. The length of your schedule, the cost based on resources, right? Personnel resources, equipment, etc. So resource management, schedule management, and cost management are intimately related to each other, would be my point to all of that. So we're going to talk about allocating resources, both technical, both human, physical, etc. And we're going to relate it to schedule and cost back again. Remember we did the critical path method, right? And so one of the tools you can use, well, okay, first, does a schedule ever fall behind? Yes, of course it does. There are a million reasons that can happen. And so one of the things you can do, one of the tools, is called crashing your schedule. And to crash your schedule, what you're really going to do is add resources, which cost money, to accelerate the activity or activities that you want to catch up on. Now realize there's a law of diminishing returns. If I have an activity that has 2 engineers and I double it to 4 engineers, that doesn't necessarily shorten my time by half, right? That there's a law of diminishing returns. At some point we get in each other's way. So but to add resources, even one, will accelerate the schedule, which helps the schedule management, but it will cost money, right? I mentioned as project managers, we're making trade-offs all the time between schedule, cost, and scope baselines. And so this is a way to change or accelerate our schedule. Now, I kind of mentioned crashing. Sometimes it's called crunching, rarely. Mostly, and the formal term is crashing. That's what you want to stick with, really. And it's to speed up or accelerate your project, adding more resources to it. There's more in the book if you'd like. And so you can create an activity slope if you wanted. You could do the crash cost. How much will these extra resources cost, minus the normal cost, divided by crash time, divided by normal time. And you create an XY axis and graph the slope if you choose to. So, and you can do, that really does tie in nicely to the critical path method. In fact, I generally crash things on the critical path. I do not crash activities that are off the critical path as a rule. So they run through an example, which is from the book, on using the activity slopes in a critical path method to demonstrate this effort. So a normal schedule might take 8 days and cost $120, right? But if I want to make it that's 7-day schedule. If I want to make it a 6-day schedule, you can see I'm crashing it. I'm accelerating some activities. In this case, activity D. And that's going to I'm going to need resources, and that's going to cost me a little bit more money. What if I wanted to make it a 5-day schedule, right? Would cost me even more, and I could maybe accelerate some of the other activities on the critical path, okay? And a 4-day schedule, the same. It just gets more and more. Now, what that does is that creates that sloped curve, that cost crash curve that I was just referencing a moment ago. And that if you wanted to graph it, it would look like this, right? And this would be normal. Normal is going to cost you the least. If you want to crash all the activities, that's going to cost you the most, right? And so the slope curve changes when I just crash activity A, or when I crash activity A and B, etc. up the line, okay? Now, another way to accelerate or make up time on your schedule, besides crashing, is called fast tracking. And fast tracking takes 2 activities, remember, called we build our schedule network model based on the precedence diagramming method. So precedence, one activity must be a predecessor, one must be a successor, right? And there's a dependency. But sometimes in fast tracking, I could take two activities and do them in parallel. Maybe if they were completely different teams that were working on them, and I didn't need any common people between them, any common resources. So I take activities that are normally scheduled in sequence, finish to start relationship, and I could run them in parallel. Notice that that will increase risk because it was scheduled finish to start in that sort of relationship for a reason. So as a project manager, be careful of risk here, right? But I'm overlapping things that were normally scheduled in sequence. I'm not adding extra resources to it, but I have increased risk because it wasn't the way it was supposed to be. So here's an example of the official pace of a project, the normal pace in the middle, things you could do in a rushed pace or in a blitz, right? It's worth pausing and studying. I'm sure you read it, reviewed it in the literature. So, but we have a resource allocation problem, right? So PERT reduces risk by getting activity times to something defendable, reasonable, but it ignores resource utilization, right? And so also with external resources, this might not be a problem because when I contract something out, it becomes their problem, right? And that's for the supplier to figure out. But either way, schedules need to be evaluated, and that's why at the end of schedule management, we do schedule network analysis, which considers resourcing also. Because remember, time is limited. The project has to be finished in a certain amount of time. That would be the schedule baseline. And it must match the cost baseline and the scope baseline. But at the same time, resources are limited. And sometimes they're fixed, right? And so we have constraints on our project. And sometimes the iron triangle cost might be fixed. So all you have is schedule and scope. And a reduction in cost would mean reducing scope or schedule or both also, right? So there's this triangulation between them, between schedule, resources, cost, and scope. Okay. Now I could do resource loading or resource leveling is another term that's sometimes used. They're similar but not exact. But resource loading describes how many resources I'm going to need at any given time. So if I have all of my engineers loaded up front in my project, I probably want to smooth that out because it increases the likelihood that I'll have engineers available when I need them, for example. So I could use a resource usage calendar, right? Here's a calendar and the various resources I need and when I will need them and how many I will need. And then you look at that and go, could I smooth that out a little bit, right? And they graph from the literature, you can read this in the book, they graph leveling those out along the way, okay? So that's resource, taking care of resources, because you don't want to have them all piled up. What if they all have to deploy or go on an emergency trip, right? Then you'd really be stuck, right? Here's another view of that same issue, which would require some of that leveling or smoothing along the way, right? And so resource leveling is going to improve morale and create fewer personnel problems along the way. Especially when an activity does have some slack, we can move that activity to shift. So if I have slack on an activity, some float, some extra time, I can move resources to activities maybe that are on the critical path. That would be resource leveling. And because of resource leveling, it may be possible to rearrange some of the activities. And that's why you want to do schedule network analysis. So when you determine your activities and you put them down in a network with precedence and successor relationships, you want to look at other options, right? Because part of that would be leveling out the resources that you need, especially with large projects. And this is just a visual of your schedule network diagram, and you're looking at resource leveling along the way to make it something more like this, smoother orientation. And so this is really about uncertainty. This is really about increasing the likelihood of success by decreasing risk, because I'm attempting to level demand along the way, and it ensures a more consistent supply of human resource availability throughout the project. And so with resource loading or leveling, I should expect disruptions, emergency, maybe some maintenance issues that have to go on. People pulled off my project for other reasons, right? And so, especially if they're a scarce resource, do not schedule them to 100%. Put it in your justification. Put it in your resource management plan, which describes how you're going to manage resources, so leadership is aware. But you want to make sure that you manage them appropriately. Okay. Now, a heuristic approach, that's a French term. Basically, it means a rule of thumb. That's what a heuristic is. So it's an approach that we call a rule of thumb that is going to result in a good solution all the time, right? And so an optimized approach, though, would use linear programming. And I mentioned deterministic optimization is a course. Deterministic operations research is a course we're going to take in the program, I believe, which is going to give you linear programming skills that will yield a best solution that is graphed along the way. Not for this course, but it certainly is doable. Some heuristic methods use PERT. Besides reducing risk, that's what it's really doing. It's a heuristic. It's a rule of thumb, right, as supporting the schedule baseline. And a rule of thumb may not be optimal, but it's very good. It's a good or best practice for a reason. That's why it became a rule of thumb. So we can sequentially step through the schedule and apply these in our schedule network analysis that I've been talking about. And by doing that, I can then move resources around to meet our priorities, right? And some common priorities are listed here in this slide. You can pause it and make your own notes from the book here. Notice the if I have minimum slack, or float, right? They're synonymous. If I have some float, I can move resources around. That helps me. We want to look at predecessor and successor activities, and you really want to look at critical activities, critical path activities, right, along the way. So those are some of the common heuristic methods. There are lots more. Your own industry will have their own. Now, some optimization methods is where you're looking for that one best solution. And the course, again, is Deterministic Operations Research, and that will use linear programming. Really, I'm going to define my constraints and my variables and create a mathematical formula that will optimize a solution for any number of issues like transportation, resource, scheduling, etc. Okay. Now, if you run a program, which we've said are related projects, you're going to have multi-schedule and resource allocation to deal with. In fact, even above a program, so it's a project, program, which are multiple projects, and a portfolio or project management office, PMO, is running all of them. And they make resource allocation decisions along the way based on availability. Okay. Now, I'm going to pause here and come back with measuring the schedule, ways to do that.